Hello, this is Ping Pong Labs presenting on ping pong serve and linear acceleration. So we have two questions that we've generally wanted to ask because we're very curious. Is there a difference between a novice's and expert's linear acceleration and ping pong serve? Can a novice's stroke become more like an expert stroke with a learning intervention? We're about to find out. Our passion. We are driven to understand whether there was a difference in acceleration between novices and experts. This is because we are curious people, and if there is a difference, ping pong teachers can be aware of the fact that acceleration might be critical for a successful ping pong serve. Visualization might be really useful for motivation, and if our intervention is successful, it supports the idea that getting acceleration right is critical. Measures. Sensor kinetic app on the iPhone. The iPhone was attached to the participant's favorite upper arm. Linear acceleration, and by the way, negative values don't imply negative acceleration. They're just a different direction for X, Y, and Z. So those are our measures.
Okay, so about the methods, first we had each participant take turns serving the ball with the iPhone strapped to their upper arm. After each serve, we stopped the data collection in sensor kinetics and save the data to the phone. Second, all participants were required to serve the ball in the corner square of a table that was marked by post-it notes. We recorded whether the ball landed within the square boundaries after each serve. Third, each participant was given 10 serves. After everyone had served, the novices were given a learning intervention. This involved the expert teaching the novice a better way to serve. Ben assisted Sam and Jie assisted Wei. This learning intervention lasted for 30 minutes. Finally, after the learning intervention had been applied, the novices served 10 more times each in the same corner of the table. All the data was saved to the phone and sent as CSV file to all the participants.
To collect the data, we create a target and let novices try to serve the ball to be within this target. If the participant serves the ball and the ball is in the target successfully, this trail is marked as 1. Otherwise, it is marked as 0.
So I just wanted to clarify the fact that although we collected data on X, Y, and Z values of linear acceleration, we focused on the Y values just for time's sake mainly. So the rest of our tests were done with Y, and for the next several slides there'll be graphs, and each graph represents an individual trial, and the data below is a paired samples test testing the difference between each trial. So here we have Sam post trial being compared to the Ben's values when it comes to Y, and it was significantly different for both both post-min and post-max. And so that was the second trial that Sam participated in.
So we compared the pre-test results of Wei's direction Y of linear acceleration and this using t-test. The p-value of minimum values is 0.93, which is not under 0.05. That means the difference is not significant. In contrast, the p-value of maximum values is 0.041, which is under 0.05. That means the difference is significant. And according to the graphs, we can also tell the patterns between Wei and Jie are obviously different. So we also compare the post-test results of Wei's direction Y of linear acceleration and Jie's using t-test. The p-value of minimum values is 0.048, which is less than 0.05. That means the difference is significant. And the p-value of maximum values is 0.633, which is not under 0.05. That means the difference is not significant.
These graphs are y acceleration values over time in the pre-test and post-test for 10 trials each. The t-test of means shows a significant increase in the average minimum acceleration and insignificant decrease in the maximum acceleration for SAM.
So, comparing with pre-test and post-test result, t-test shows that the p-value of the comparison between pre-test medium and the post-test medium is 0.04. Since it's under 0.05, so we can say the difference is significant. And the p-value of the comparison between pre-test maximum and the post-test maximum is 0.11. It's obviously under 0.5. No, it's obviously not less than 0.5. So we can say the difference is not significant. But according to the graphs, can tell that the scopes between two processes is very different, which means the acceleration is getting bigger.
The results. Minimum and maximum values were taken of each ping-pong swing in Excel. We chose these values because it was the easiest way to compare linear acceleration for serves that took different amounts of time. We compared the differences of the min and max values for each dimension of linear acceleration. So we define accuracy as hitting the ball successfully in the target. This graph shows that we in the pre-test did not hit any balls into the target. She hit the balls in the post-test 30% of the time into the target. In the pre-test, Sam hit the balls into the target 40% of the time and 10% of the time in the post-test. G hit the balls in the target 40% of the time and Ben 20% of the time.
For the implications, looking at the data, it suggests that there was an effect in the intervention. With maximum acceleration convert closer to the pro-acceleration after intervention and achieved a significantly higher accuracy. The 0 balls to fall in the target.
Limitations. Small sample size, 10 trials with 1 hour's time. If this study were to be conducted on a larger scale, there should be more trials over a longer period of time. We only focus on Y due to time constraints, but ideally X, Y, and Z should be analyzed. Each variable could produce a different outcome and pattern.
Thank you.